For nearly a century, the safety of commercial aviation has rested on a fundamental pillar of redundancy: two sets of eyes, two sets of hands, and two human brains working in unison. But as we entered 2026, that pillar was on the verge of being dismantled. Airbus, in partnership with major carriers like Cathay Pacific, was aggressively pursuing Project Connect, a radical initiative aimed at certifying extended minimum crew operations. The goal was simple: use advanced AI and automation to allow a single pilot to manage a wide-body jet during the long, quiet hours of cruise flight while the other rested. It was the first step toward a future where the co-pilot might eventually disappear entirely. To the accountants and executives, it was a multi-billion-dollar solution to a crushing global pilot shortage. To the engineers, it was the ultimate proof of their technological mastery. But to the regulators, the unions, and the flying public, it was a safety red line that could never be crossed. In February 2026, the dream of the single-pilot cockpit didn't just stall. It was effectively executed by a new federal law that has fundamentally reset the trajectory of aviation innovation for the next generation. To understand why Airbus and its partners were willing to bet billions on this radical cockpit, we have to look at the math. By 2026, the aviation industry was navigating an era of record-breaking passenger volumes, with numbers projected to reach an unprecedented 5.2 billion travelers annually. While industry revenues were on track to top $1 trillion for the first time, profit margins remained razor-thin, hovering at just 2%. The massive backlog of aircraft orders, stretching into the 2030s, created a desperate need for more pilots to fly them. Labor is one of an airline's largest controllable costs. If an airline could operate a long-haul flight with 2 pilots instead of 3 or 4, or a short-haul flight with only 1, the savings across a global fleet would be astronomical. This economic pressure birthed Project Connect and the European Across Research program. They weren't just experimenting with gadgets. They were building an entirely new operational model designed to manage pilot fatigue and labor shortages through sheer computing power. The technology Airbus was developing wasn't about replacing the pilot with a dumb autopilot. It was about workload optimization. Projects like Flight Pulse were already connecting operational data directly to cockpit decision-making. Airbus envisioned a collaborative cockpit where AI monitored every system, cross-checked navigation data, and communicated with a highly specialized ground station that could take remote control of the aircraft if the lone pilot became incapacitated. At the 2026 Farnborough Air Show, the industry was buzzing with advancements in a unified data layer designed to transform aerospace decision-making. We were seeing the rise of Iridium's PNT ASIC, a tiny chip capable of protecting aircraft from the surging threat of GPS jamming and spoofing. In theory, the ghost in the cockpit, the AI could fly more precisely, react faster to emergencies, and never get tired. But while the silicon was getting smarter, the human element was proving to be much more unpredictable. The primary argument against single-pilot operations wasn't that the computer might fail, it was that the human might. Between 2019 and 2024, European aviation authorities recorded a startling 287 pilot incapacitation events. That is an average of 1 medical emergency in the cockpit every 6 to 7 days. In a dual-pilot system, a heart attack or a stroke is a crisis, but it's a manageable one. The other pilot immediately takes control, declares an emergency, and lands the plane. In a single-pilot environment, that same event becomes a life-or-death race against time for a remote operator or an unproven autonomous landing system. Labor unions and pilot associations were quick to point out that cockpit redundancy isn't just about flying the plane. It's about the continuous cross-checking of human decisions under extreme stress. The public agreed. Survey data revealed that 81% of people strongly supported maintaining a minimum of 2 pilots on every flight. This overwhelming lack of public trust became a hard structural ceiling for the industry's ambitions. All the research, all the lobbying, and all the test flights came to a grinding halt in February 2026. A binding federal aviation law was signed in the United States that removed all ambiguity. It requires, as a permanent statutory baseline, a minimum of 2 qualified, fully rested pilots on the flight deck of all commercial passenger flights at all times. This law didn't just prevent the removal of pilots, it effectively killed intermediate concepts like extended minimum crew operations, EMCO, where one pilot rests during the cruise phase. The law mandates a continuous dual pilot presence across all phases of flight. The impact was immediate and devastating for Airbus. Because the US is the world's largest commercial aviation market, any aircraft designed for a single pilot would now be unable to fly the world's most lucrative routes. Shortly after the US law was signed, the European Union Aviation Safety Agency, EASA, reached its own conclusion. Current technology simply cannot guarantee a level of safety equivalent to 2 humans in a cockpit. The world's 2 most powerful regulators had aligned on a conservative baseline, effectively ending the single-pilot revolution for a generation. So where does this leave the future of flight? The trajectory of cockpit innovation is shifting. We aren't seeing a push for fewer pilots anymore, but for better supported pilots. Manufacturers are now focusing on human performance augmentation, using AI to reduce fatigue, improve situational awareness, and simplify complex decision-making within a permanent 2-person framework. Airbus's radical plans may be dead, but their legacy lives on in the tools being built to make every flight safer. We are moving toward a future where the computer is no longer trying to take the pilot's job, but is instead acting as a powerful, silent guardian for the humans at the controls. The single-pilot dream failed because, in aviation, we learned that technology is a brilliant servant, but a dangerous master. In our next episode, we'll explore the air taxi revolution, why eVTOLs are finally hitting the streets of Dubai and New York, and if they will be the ones to finally master the art of the pilotless flight. Don't forget to like and subscribe to stay updated on the future of flight.